Everybody, today we will discuss the next topic of the photochemistry, that is the photocyclo addition of ketone with unsaturated compound, and this reaction is otherwise known as the Paterno-Pucci reaction. In this type of the reaction, we have the two starting material, that is one is a carbonyl compound, it may be aldehyde or ketone, and the next one is an unsaturated multiple bonded compound. So here in this example, our starting material is a ketone and an alkene. So first of all, the ketone, we know that the ketone is highly reactive towards a photochemical reaction due to the presence of the three different type of electron, non-bonded electron, pi electrons and sigma electron. So carbonyl group absorb the radiation and to form an excited state. First of all, it forms the singlet state, then it undergo the triplet state, and finally it undergo the homolytic cleavage of the pi electrons and to form the two new radical. One is in the oxygen radical, the second one is the carbon radical of the carbonyl group. Then during this time, the alkene also undergo the homolytic cleavage of the pi electrons and to form the two radical. One is a secondary radical and the other one is a tertiary radical. We know the stability order of the radical, that is tertiary greater than secondary. And first of all, we have to stabilize the most reactive radical. Here we can see that in the carbonyl group, most reactive radical is the oxygen radical, because oxygen radical is highly unstable, and in the alkene the secondary radical is highly unstable. So the oxygen radical combine with the secondary radical of the alkene and to form a diradical triplet. See here the diradical triplet I have shown in the bottom of the slide, and diradical singlet is also formed. After that, the singlet radical combine together and to form a cyclic compound. See here we will get a cyclic four-membered ring in which one of the member is the oxygen, and all the other vertices of the carbonyl group are carbon, of the cyclic ring are the carbon, and which is substituted. Then we are again moving to the another example in which only triplet excited state participate in this reaction, and this is a 2+2 cyclo addition between a carbonyl group and alkene and to form the four-membered oxetane. See here in the another example, the starting material is a ketone and alkene. Here this alkene is highly unstable because it is no substituent is present in the multiple bonded carbon. So during the irradiation, the carbonyl group will absorb the radiation and to form an excited state which is in singlet, then it form the triplet state and to form the homolytic cleavage during the absorption and to form the oxygen radical and the carbon radical of the carbonyl, and during this time the multiple bonded alkene also undergo the homolytic cleavage and to form the two radical, and after that the oxygen radical, highly unstable oxygen radical, combined with the radical of the alkene. Since in alkene both the radical are the same, so we can combine with any of the primary radical of the alkene, and after that the radical which is present in the carbon of the carbonyl and the alkene combine together and to form an four-membered oxetane. Now we are moving into the another example in which our starting material is ketone and an alkene having only one substituent. So in this case we will get two different products. One is major and the other one is a minor product. So here in this mechanism, the carbonyl group absorb the radiation and to undergo the excitation state. First of all, singlet, then to triplet, then it undergo the homolytic cleavage and to form the two radical. After that, it is added to an alkene, and one of the carbon atom of the alkene is attached to a substituent R. So, first of all, we have to stabilize the unstable radical. So, the oxygen radical combined with the primary radical. See here, oxygen radical combined with the primary radical of the alkene. After that, the secondary radical of the carbonyl group and the secondary radical of the alkene combined together and to form the final product. So, the major product is the major product is the oxetane, in which R group is opposite to the oxygen atom. Okay, this is because we know that in oxetane the oxygen radical is highly unstable and the primary radical of the alkene is highly unstable. So, it will combine together and to form the product. Okay, so next example is the alkene combined with a carbonyl group, in which alkene is attached to an electron donating group. See here, if our starting material is a cis compound, our major product is also cis, and our starting material is a trans compound, our major product is also trans, and addition is very much similar to the previous example. Then, if our alkene is attached to an electron withdrawing group, and if it is a cis, we will get the same cis compound, and if it is a trans, we will get the same trans compound in Patonabuchi reaction. Now we are moving into the another example, in which the first example we can see that there are two carbonyl group and Patonabuchi reaction occurs only in one carbonyl group, and the alkene is a part of a ring and it will combine together and to form this product. And the Patonabuchi reaction is also occurs in the same molecule in which the two starting material, that is carbonyl group and alkene, is present in the same molecule. So internal combination of the carbonyl group and alkene occur, and again this is a 2+2 addition and this is the final product. I hope that you understood the concept. Thank you.